take the card, use it as the index, and then assign the card to that position within the table. So now I've got this weird sparse table that has no integer indexes at all, but has direct references to each card. So let's keep looking for the card usage here. All right, so I'm going to take a moment here. I'm going to flip over to the card Lua code. If you remember in our previous discussion, I created 3 different card flipping methodologies. Card flipping 1 simply immediately replaced the card with the image, or it hid this part and showed the image. Card 2 squeezed it in, changed the X scale so it gave it the impression, the visual impression that it was flipping. And flip 3 scaled the X and the Y so it zoomed out, and then when it came back in, I showed the image. The one that comes with the game by default, the one that's hooked up, is flip 2. In each of these cases, if you look at the code, for example, let's look at flip 1 because it's shorter. It comes in and it does the work to flip, or if you're looking at flip 2, it comes in and it does the work to flip, and then what it does is it uses my little shorthand function, post, which is the same as runtime dispatch, except that post in this case is a little smarter in assembling the data. Little easier than using runtime dispatch. And what it does is it sends a custom event out into the ether for anybody who's listening. Any objects out there, any listeners that have been set up previous to this point that are listening for this event will receive it, and they will receive a table that has an entry called card referencing the card that we just flipped over. So in a nutshell, we flip the card, we post the event on flipped, and then out in the ether, other objects and listeners are waiting to hear, hey, on flipped, now I need to do something. And in this case, our game manager, in a sense, has got an event listener that is waiting for this event. And so we created it here. And down below, we said, listen, using my shorthand notation. This is the same as runtime add event listener. It's just nice shorthand, so I don't have to type so much. Listen for this event, and the listener that needs to do something with it is public on flipped, which is this function that we are currently defining right here. So we flip the card, it calls this, and the part that we care about is basically some logic here that compares the 2 cards that got flipped. What it does is you flip one card, it says, oh, I don't have any cards yet that I'm keeping track of. So this card here, I don't do anything yet. I just keep track of it, and I wait for another flip event. So we flip, the code executes, it says flip count +1, add the card to our list. If flip count is greater than 1, that means we've got 2 cards, then we do something. Otherwise, nothing. We just fall right out of the routine. And this current cards thing is another one of those tables that I created at the top of the file. I didn't really go into this. Let me get back here. But when I flip the second card, what's going to happen here is it's going to increment flip count, so that'll be equal to 2. It's going to store the card in there, and then we're going to get to this bit in the routine, and it's going to say, flip count is now greater than 1. In other words, it's 2. Now I need to do a comparison. And what it does is it says card 1 is equal to card 2. And we discussed this previously, but when we set up the cards, we set up a little field on it that gives it the image number of the card. Sorry about that. That was my game telling me I lost. I've got to turn that off. Yes, no, it's a correct. I'm giving the correct example here. It always happens when I'm describing it. It's like the computer's telling me, no, you got it all wrong.
No.
No. So, are the cards equal? Yes, they're equal. All right. Go ahead and shrink those cards out, delete them, and take the reference to card 1 and card 2 and just set those entries to nil. So recall, when we created the card, We had a reference to the card. We used it as the index, and we assigned the value. This current cards 1 is that same reference. We've clicked on it. We've got some code out there that did something with it. It posted the event on flipped, and it passed that card along right here as an argument. We extracted that information right here, event card, stored it in our little temporary table. When we had 2 flips, we compared them and we said, yes, they're the same. We did our remove it from the board work, shrink it, and at the end it removes it, calls display remove. And then we removed those 2 references from our table. So at this point, there are 2 fewer cards in the table.
So Ed, it may be obvious to everybody. I just want to stop and point out. So the .num on each of those cards there on line 130, that is the defining factor that tells the system that the 2 cards are the same.
Absolutely. Let me just show you where that's set up, just in case there's any.
Because I think that's the key point that people might not understand is, well, how do you know the 2 cards are the same? I mean, they're memory addresses and all this other business. How do you know?
So as you recall, if you will recall, is earlier on we made our board and we called this builder function in card Lua, called create, and we told it the display group to put the card in. We told it the X and Y position, the width and height, and we passed a number. So we passed in a number, and what this number is, it's the number of the image. If we look in our images folder, we'll see a bunch of files, 1, 2, 3. Basically what we've done is, as we built this board, we created a table containing a list of numbers. We randomized that table, and in that table there were 2 1s, there were 2 2s, there were 2 3s. So am I making sense here? We created a table, we put 1 1, 2 2, 3 3. Then we randomized the contents, we shuffled the table, so it might be 1, 3, 5, 2, 1. The order is whatever it is. Then we iterated over that table, and for every entry in the table, we did this in a previous episode, we call public create and we pass the index that is at that point in the table. So entry 1 in our table, the index is the value is 2, which means build card 2. So we build card 2, which draws this image here for the Corona Crush example artwork, and then down here in the code, after we have called display new image rec to draw the card, and the card itself is a display group, so we're going on the Wayback Machine here. We create a display group, which is our card, and then into that we insert a rectangle and we insert an image, because if you'll remember, these cards are a composite of a display group, which contains the background rectangle and the image, because we need that to do the flipping animation. I see you've got this sort of...
No, you're good. You're good. No, good. I'm waiting for you to get to that next line, which is that where num comes in.
So, but the card is the sort of like the master, the owner of the whole thing. This is the thing that contains all the details about it. So, after we've made our background rectangle and after we've made our image, I simply assign a field called .num where I store 2 or 4 or 6 or whatever the number was for the image that I used.
And there on line 120, it looks like that's being concatenated into a file name.
Yes, and on line 120, basically what we're saying here is create a new image rect, put it in the group card, which is the display group we created right up here, and then look in path images / means concatenate. So if this was 2, this would be images /2 / I'm sorry, images is the folder for the
Candy Crush or whatever.
Candy Crush or Corona Crush, Lost Garden, Niku Fruit, whatever, because I give you a bunch of options, / the number of the image and .png.
Right.